Installing OpenShift can be a mystery if you're used to bare metal operations. OpenShift and Kubernetes installs follow a different logic, so I'll walk you through the whole process, and by the end of this video, you'll be more comfortable running it, troubleshooting errors, and tailoring installs to your needs. I'll also show you how Digital Rebar allows you to skip the whole process with a zero-touch install. To start with, you'll need servers and a network. OpenShift installs CoreOS as the base OS. You could also use RHEL or another Linux distro, but we're focusing on CoreOS because it introduces some unique challenges in the recommended install path. CoreOS is immutable, so you don't install or post-configure it. Instead, configuration is baked in up front. That's a shift from typical admin workflows, and we'll go deeper into how that works later on. Ultimately, those pieces become your Kubernetes cluster. A production Kubernetes cluster requires a control plane with at least 3 nodes and 1 worker. For this video, we're assuming you are targeting bare metal. To complete the cluster, you also need supporting infrastructure. DNS, a load balancer, a container repo cache, and on bare metal, you'll have to have a hardware lifecycle manager. In cloud installs, the provider handles the lifecycle management, but on bare metal, it's your responsibility. Hardware lifecycle management requires that you have an out-of-band control network for BMC such as Redfish or IPMI, and users often have a separate management network. We separate these functions from the Kubernetes control plane and application networks because they serve different roles. The management network typically supports PXE booting and administrative access. Altogether, we have an out-of-band network, dedicated management network, and then additional networks, each with different functions. These could be physically or logically segmented. Now, we're aiming for this to become a fully configured OpenShift cluster. But how do we get there? Let's take a step back and figure out what's going on as we build this cluster. We start with very little in the environment, just our servers. The first component to come online isn't a node at all, but the lifecycle management control system, which uses the management network for PXE booting and provisioning. Most people do this with multiple networks, which we recommend for higher performance. For lifecycle work, you'll want a primary management interface and an out-of-band control network. Your servers also need access to container repos, load balancers, and DNS to come up properly. For any bootstrapping environment, you need a basic DNS with your host entries in it to get running. A lot of installs fail by assuming that DNS can be pre-configured statically. That is a lot of overhead and prep work. Ideally, your lifecycle management configures DNS dynamically as servers boot on different interfaces. You'll also need a virtual IP address, known as a VIP. While we're not ready for a load balancer yet, we do need a VIP to prepare for one during the bootstrap process. Set this up early or let your lifecycle manager do it. At this point, we can bootstrap our first server. As we boot, we're going to take it through a discovery cycle where we configure out-of-band management. You must also correctly set BIOS, firmware, and RAID subsystems. Now, our server's ready to go. It is important to note that this step is going to repeat multiple times. You will be continuously updating BIOS, firmware, and RAID. You need to maintain out-of-band control because you will need to drive the server through multiple life cycles. This capability is absolutely essential for bare metal. Next, we install the OS. With Digital Rebar, we start with a discovery OS to handle these lifecycle tasks, and then reboot to the target OS. To install CoreOS, we use a process called ignition. You supply an ignition file when booting CoreOS to define how it configures itself. This file must include hardware details, NICs, drivers, and other configuration components so the system can set itself up correctly. You can't just build the ignition file blindly. It must reflect discovery data and be available during every CoreOS boot. That's a key job for the lifecycle management server. It has to store and deliver ignition files that are unique to each server. Since CoreOS is immutable, it configures itself at every boot. There are other approaches, but this video follows Red Hat's recommended methods. If you want alternatives, contact us and we'll walk you through them. With CoreOS ready, we can start the OpenShift bootstrap. This install model uses Kubernetes to build itself into the cluster. We rely on the system we're installing to do the operations. To make that work, you have to supply an initial manifest to build a foundational Kubernetes cluster. Manifests are YAML files that explain what containers, services, and configurations are necessary to run Kubernetes. we're going to start with a foundational manifest. Those are enough to bootstrap the system. They rely on containers, so we have to have a container repository cache to download them. If you're connected to the internet, that's great. A lot of enterprise customers aren't fully connected to the internet and have to rely on a local cache, which needs to be specified in the manifest. You'll also need to rely on your DNS and VIP at this point. Once the manifests are in place, the system downloads containers and bootstraps core Kubernetes infrastructure. Notice, none of this is a playbook install. It depends on you assigning correct manifests to the minimal Kubernetes as it starts, and then allowing it to take over, downloading, installing, and managing, and connecting systems using an interconnection techniques inside of Kubernetes called Custom Resource Definition, or CRDs. OpenShift especially uses a chain of CRDs that trigger one another. Each CRD enables the next. The system cascades through CRDs and containers to assemble all required functions. To add advanced capabilities like OpenShift virtualization or AI, you extend the manifest to include additional CRDs. This is baked into the design of your initial manifest set. A lifecycle manager or script supplies these ignition and manifest files. At this stage, you have a working Kubernetes cluster. It might be just one node and no workers, but the core services are running. Now that you have a Kubernetes managed DNS and load balancer, you can start bringing in additional controllers and workers. The next thing you're going to do is repeat this whole process with additional controllers in the system. We're going to skip over that part because it's the same as what we just did. Next, we'll focus on adding workers. The primary difference between controllers and workers at this point is their assigned manifests. To add workers, boot a server into the environment and go through the same discovery and configuration steps. Advanced setups do this in parallel across multiple servers instead of sequentially, like we're showing here. From there, boot the server with its ignition file. It is very important that you treat the ignition file as layered templates so that you can have consistent repeatable components with base, environmental, and machine-specific layers stacked in. Once booted, apply manifests that pull in containers and configure the worker node. Now you have a basic OpenShift cluster running. It's fully managed by OpenShift and integrated with the Lifecycle Manager. You can rebuild, update, or reconfigure at will. But this is not a set it and forget it system. You need to constantly tune ignition files, add manifests, and evolve your cluster. Think of the cluster as a layered stack of capabilities. Store all of these ignition files, manifests, and configurations in a Git repo or similar source of truth. Your Lifecycle Manager should build and track all of it. That's exactly what Digital Rebar does. Digital Rebar is the Lifecycle Manager and automates the entire OpenShift install. It's zero-touch, completely scripted, right out of the box. It handles server lifecycle, out-of-band management, RAID, BIOS, firmware for controllers and workers. It manages networks, ignition, CoreOS booting, and files across the environment using templates. We handle everything in layers so that you can finely tune your ignition files. We also support other operating systems if you have a different strategy. Having a dynamic bootstrapping DNS is critical and native in Digital Rebar. We provide foundational DNS and VIP management, and then happily coordinate with Kubernetes managed DNS after bootstrapping. Digital Rebar can also push manifests into your Bootstrap or running Kubernetes cluster to manage additional functions. As you can see, Digital Rebar supplies all the foundational services and capabilities to operate OpenShift on bare metal. We've made the experience cloud equivalent, and with the added benefit of full control over your hardware. I hope this explainer was helpful. If you have any questions and want to see the process in action, please contact us. We're happy to take you through a technical demo and show you exactly what this process looks like.